Okay, I hope this works. I have already recorded these once, and I found out after the fact when I went into a Zoom meeting with the other math teachers that my microphone was not turned on. So hopefully it is working this time. I will check in between the first one and the second one and make sure that it's working. All right, so we are doing double angle identities. These are your double angle identities. Because you've been using identities, this should go fairly quickly. I'm not going to derive them for you, as I will only tell you this: cosine 2a is the same thing as cosine a plus a, because that would equal cosine 2a. So you can probably figure out that they are derived from the sum and difference identities, but I'm not going to derive them for you because I think you could probably do that yourself. We're just going to use them, just like we've been using everything else. And so since you've been doing identities and working with them, this should probably be pretty simple. So this time, now you'll notice I have 3 different cosine double angle identities. If you'll notice, this one involves both cosine and sine, whereas the other 2 just involve one of the ratios. So that's kind of what helps us determine when we use what. It depends on what we already know. Now, in this case, they've given me cosine theta is 3/5, and that sine theta is less than 0. So real quick, if sine theta is less than 0 and cosine is positive, we know that this is all students take calculus. Sine is positive in quadrants 1 and 2, but negative in 3 and 4. So we know that sine's going to have to be negative. And cosine is positive, which means we have to be in quadrant 4 for these. So my sine value has to be negative. Now, I only know cosine this time, which would mean that if I don't do anything else, I can't use this particular identity because I don't know sine. However, I could use either my sine squared theta plus cosine squared theta equals 1 and find sine, or this one's pretty easy because cosine is 3/5. 5 is the hypotenuse always, which means this is a 3/4/5. So sine is going to be negative 4/5 because it's still over hypotenuse, and sine is negative in this case. So I actually do know sine and cosine, which means I can use this first identity. So I'm looking for sine 2 theta, cosine 2 theta, and tangent 2 theta. So first, let me change colors real quick. Let's do cosine 2 theta equals, well, cosine 2 theta equals cosine squared theta minus sine squared theta. So that means it equals 3/5 squared minus negative 4/5 squared, which is 9/25 minus 16/25, which is negative 7/25. So that's your first one. Let's do sine. So sine 2 theta equals 2 sine theta cosine theta. So that's going to be 2 times negative 4/5 times 3/5. Multiplication, you can do it in any order. I'm going to put that 2 over 1, make it negative 8/5 over 3/5, which is negative 24/25. And then the last one is tangent 2 theta. Hope I have room. I'll try to write small. It's kind of hard to write small with this little thing. All right, so tangent 2 theta is going to be 2 tan theta over 1 minus tangent squared theta. Okay, we didn't write tangent up here, so let me go back up and write it. If I know what sine and cosine are, sine is negative 4/5, cosine is 3/5. Remember, tangent is sine over cosine. So it's going to be negative 4, that's from the sine, over cosine of 3, because the 5s would cancel out. So it's negative 4/3. So when I'm plugging in, I get 2 times negative 4/3 over 1 minus 4/3 squared, which is negative 8/3 over 1 minus 16 ninths. Let me scroll just a little bit, get myself a little bit more room. So I have negative 8 thirds over 9 ninths minus 16 ninths, which is negative 8 thirds. I'm now changing this fraction bar into just a division symbol, divided by negative 7 ninths. If I keep, switch, flip, simplify that, I get negative 24 over negative 7, which is 24 sevenths. And that is all for that one.